So my name is Renata Yaciene. I'm application engineer at AGA-CAD. Today with me also is Valentas Blisevičius. He is our structural engineer.
Hello everyone.
Today we have a web session about easier design of concrete structures using Revit apps. So first, I would like to start with introduction and with saying a few words about our company. Our mission is to building BIM design together, and in this way we help reduce stress in BIM processes while saving our clients time and money by eliminating unnecessary BIM tasks. Solutions. We have solutions for BIM execution and lot quality control. And we are Autodesk authorized developers, and we are professional developers of Revit add-ons. We are operating since 1991. At the moment, we are partners of Autodesk for 25 years. At the moment, we have more than 8,500 commercial licenses in 129 countries, and we continuously develop our existing solutions while also creating based on the needs of our clients. The most important value of our team is customer alignment. We strive to respond to the needs of every client. And our work is driven by our customers' needs, and there are the benefits we strive to deliver to our customers. It's less stress in daily work, easier BIM, and satisfaction with the return of investment. This is our promise to our customers, reducing BIM stress. At the moment, we have many products, and actually we can divide them into 9 parts. Here in the top we have solutions for MEP engineers. Here we can have products for fire protection systems, for air terminals, for adding radiators into the projects, for distributing hangars. Then we have cut opening. It's very powerful for making openings around pipes, ducts, cable traces, and conduits. Then we have BIM3 Manager. It's very powerful for managing parameters and parameter values that are used in the project. Then we have one group with the name Sustainable Design. Then we have a group with the name Smart Browser. Here you can find solutions for browsing your families and for managing your content. Then we have wood framing. Here you can see solutions for making wooden frames for the walls, floors, and the roof. There are very powerful solutions for making wooden trusses, for making wooden rafters, and other frames for the roof. Then we have metal framing. Here you can find solutions for it's the same scenario as it was with the wood. Just here we're using metal frames for generating trusses automatically according to the roof shape, for adding metal frames on the walls, and the same for framing your floors. Then we have smart assemblies. It's very powerful for making shop drawings. And tools for Revit. Here you can find a group of different solutions for documentation and for modeling. So today we're going to talk about BIM3 Manager, smart assemblies, cut opening, and smart walls, smart floors, and insert elements. Actually, insert elements is included into the BIM3, so sometimes I will be showing it from the BIM3, and Valentas will be showing it from the insert elements like a separate product. But actually, the functionality is included into the BIM3. So, smart floors. This is extension for Revit that provides a set of tools for making floor slabs. Then we have smart walls. This extension for wall management, distribution, and changing the wall joints. Then BIM3 Manager for managing parameters, parameter values, and for inserting additional elements into the project and into different project places. And then cut opening. It's very powerful for inserting openings automatically. And smart assemblies is for making and preparing shop drawings. So now I'm going to my Revit project. Let's start from the very simple design. First that I'm going to use is smart walls. This is a product that goes for managing walls and for managing joints between wall ends. So the first thing that we can do, we can disallow joints. Here in my case I have the wall, and if we take a look into the properties, this wall is created using two wall layers. So sometimes architects, they need to split the walls, and they need to work only with the architectural side of the wall and with the design of the wall from the external side, for example. And structural engineers, they need to have their own core layers, and they want to make analysis, they want to prepare prefabricated panels. So that's why we have created functionality with the name decomposed walls. After decomposing walls, the tool will split those wall panels into separate pieces. So right now, architects, they will be able to work with the finishes, and structural engineers, they will be able to work with the core layers of the wall. Now the tool automatically will create it's automatically created the new types, and the new type will contains the new type name will contain the material name that is used in the layer, and then the thickness of the layer. Now we can disallow joints. Before disallowing joints, we can take a look into the gaps. This is the list of all wall types that are used in my current project. Actually, not only used. For example, if it's a white color, then we can understand that this wall is created in this project, but it's not used yet. And if it's green, then I can understand that this wall type is already used in my current project. So here I can add different gap distances for different wall types. Now, after selecting those walls from my project, I can very easily disallow joints. After disallowing joints, you can see that the tool automatically created gaps, and anytime we can take a look into those gaps, and we can shorten, we can change the direction of the gaps in different scenarios. So at the moment, all those walls are disallowed, and then we have gaps between those wall types. Here we have 0 because I have had such option in my configuration that this is a 0 gap between the internal side of the walls. And now, after disallowing joints, we can also add gravity points. For example, if we have a wall, we can very easily with smart walls insert a gravity point. Let's make transparent, and as you can see, this is additional family inserted. This is generic model family, and also if you want, you can modify this family, but here the tool will insert the family exactly to the gravity point location. After working with smart walls, we can continue using BIM3 Manager. First that I'm going to do, I can go to the BIM3 Manager, and BIM3 allows you to make filters and to understand what situation you have with the walls. And after selecting the rows in this table, you will be able to see that selection in the project. So you will understand what exactly walls you are selecting. At the same time, you can add additional parameters if it's necessary. If you would like to see, for example, the width of the wall panel, so you can also add this parameter into this list. So as you can see, the parameters are displayed as columns, and every element is displayed separately as a separate row. And in the left side, you can make filters. At the moment, I have used level and type, but at the same time, you can use any other parameters if it's necessary. So, for example, I can filter all my concrete panels from the level 2. And now I can modify the values. Let's say if I would like to renumber those wall panels, I can very easily go to the functionalities that I can apply for those wall panels. Here you can find all functionalities that you can use for selected elements. So let's say I can very easily renumber elements. Here we have sort mark, that's very powerful for numbering elements. And let's say I'm going to renumber the walls, and every wall will have unique number. So I'm using instance ID for numbering my walls. Then in the final result, I would like to have the W in the beginning, and my numbers will be created using 2 digits. And after pressing OK, now the tool will renumber all those wall panels, and actually the tool automatically will write those values into my parameters, into my properties. So as you can see, we can go directly to the project, and there is no need to close BIM3 dialog. You can go into the properties and you can see the numbers. One more thing that we can do, we can very easily add additional and calculate additional values. Let's say we would like to write X and Y coordinates for the wall start points. And here I can create a new parameter. It's a start point, X and Y. And the tool will create additional parameter. This parameter is shared. Also, it's displayed with a blue color, so you can know that this parameter is shared, and you will be able to use that parameter in your schedules and in your tags. And one more thing that we can do, we can also insert additional elements into those walls. For example, we can go to insert elements, and here we can choose any element from my project. This is the list of all elements that are loaded into the current project. So I can select, for example, the ground tubes. This is phase-based element, and here I have different rules. I can put this element on the bottom face or on the top face of my wall segments. At the same time, we can add start and end offsets from the beginning and from the end of the wall. Then we can add the distances between the ground tubes. And after insert to model, okay, there are 34 elements inserted, and we can close the dialog and we can check it here. Okay, I will make it transparent for we could see those changes better. So those tubes, they are automatically inserted, and this is like regular family. So if you don't want to have it above the door, you can eliminate it, or you can move that. Those families, they are just general families, and you can insert them according to different rules. But still, those families are like separate families. It's just like you have, if you would insert it manually, so it's the same way, just we have distributed them automatically. So after distributing those ground tubes, we can prepare shop drawings. So now I'm going to select Smart Assemblies. It's very powerful for making shop drawings. So first I'm going to select my concrete wall panel with the elements with the ground tubes, and now we will make shop drawings. So here we have Smart Assemblies, and after pressing Create Assembly, we have to pick configuration. So here you can predefine your own configuration with your own views, with your own rules, how you would like to insert dimensions, and what kind of views you would like to have, what kind of schedules. And after pressing Create, now the tool will create assembly for our selected panel. At the same time, the tool automatically inserted the gravity point, because also Smart Assemblies has such possibility. And now we can check results. So here we have a 3D view. As you can see, the tool automatically collected ground tubes into the assembly. And then we can check the front side view. We have dimensions for the opening. We have dimensions for the hosted elements. We have the totals in the end. Then we can check the left side view, the top side view, some section maybe view, then material takeoff. Here we have material takeoff with real materials that are used in this assembly. At the same time, we have a part list. Here we have the counts of elements that are used in the assembly. At the same time, we have the real element mass. And now we can put those views into the sheet. Let's say I'm going to use here front side view. Then the top side view will go here, then the left side view. Then here we are going to add 3D view. Then material takeoff will go here, and material and the part list will go here. So after making the first sheet for one assembly, we can go to shop drawing configuration, and we can go into the sheets, and we can say that I'm going to use the sheet as a template for making my future assemblies. And as you can see, configuration for the shop drawings is very easy. In the Schedules tab, you can find the schedules that were created for my assembly. So it's a part list, material takeoff. At the same time, you can select your own schedule as a template for the assembly schedules. You can add different schedules, and as many as you need. Then here you can find configurations for the views. So like in my case, I wanted to have the 3D view with architectural elevation template. As you can see, it's very easy to make your own configuration, because you can create your own view template and you can apply that view template for every view. Then we have here section view, the front side view, the left side view. Also in the front side view, I would like to have the text, so also you can select it here. And every view will be dimensioned, and this is dimensioning rules. We can go and check dimensioning rules in the separate dialog. This is the list of all dimensioning rules, and here you can predefine the rules that you need. So here you can predefine your own dimension styles that you're going to use for the commands, for the totals. Then if you want, we can add dimensions for non-standard cuts, for the standard cuts. So it's very easy to predefine your own rules. Then separate tab for adding dimensions for the openings. Then we have hosted metal and hosted concrete details. This is the rules. Here you can find rules that will go for adding dimensions on the metal details. So again, there are different options. You can add dimensions on every face of element. At the same time, you can join it, and you can show only the center line of the metal detail if it's necessary. Very similar with the concrete elements. Then we have a separate rules for adding dimensions for the rebar and for adding nodes. Also, if you want, as in our case, we added dimensions and we added the text nodes for every dimension chain. So After setting that configuration, we can save that, and we can come back again into my previous project. Now I'm going to select this wall. Okay, let's make it transparent. And now we can create assembly. Okay, I'm going to use the same configuration rules. So now the tool will collect all hosted and nested elements from the for this wall segment. The tool will add dimensions automatically, and then the tool will place those views into the sheet. Okay, so we can open this view and we can just go directly into the sheet. So here we have those views, all those views, so they are added automatically into the sheet. So we have dimensions, we have 3D views, we have the schedules, we have the part list with the masses, and so on. So Smart Assemblies is very powerful for making shop drawings. And one more example that I'm going to show you is an example with a rebar. Actually, we have improved Smart Assemblies some time ago, and we added possibility to calculate rebar weight and rebar masses. So let's make assembly for such wall panel. For such wall, I have prepared another configuration, because here I'm going to create additional views with showing the rebar and additional schedules. Okay, so let's make assembly. Okay, and now let's check results. So here we have a regular front side view without rebar. We have a gravity point. We have dimensions on my hosted elements, and we have a separate view for the rebar. Then we have a regular part list with elements and with element masses, but at the same time we have a separate schedule for the rebar and for the rebar element masses. And here we can see the totals in the end. And if we come back again into our project, if you select the element, actually you can go into the properties, and here you can see the total weight for the total assembly. Okay, one more functionality that I'm going to show you. Here we have a project with the ducts and pipes. It's MEP project that is linked into my structural project. And here in the separate project, here we have those ducts and pipes, and they are linked into my structural project. So now what we are going to do, we are going to create openings around those pipes and ducts if they're creating from the linked file. Actually, in my case, right now I have a scenario when MEP file is linked into my structural model, but in the same way it will work if I'm linking a structural model into MEP project. So it doesn't matter what kind of link you have. Also, you can work with a central model, with a central file, and you can have all those pipes and ducts in one project together with the structural elements. And also, if your MEP guys are working with any other software, not with Revit, here you can very easily insert EFC file. So also the tool will automatically cut openings around those ducts and pipes, even if they come from EFC. First that I have to do, I have to run interference check. I have to find interferences between walls, floors, and pipes and ducts that comes from my linked model. Okay, we have to export that interferences into separate HTML file, and now we can go to cut opening. So first we have to read interference check data. I have to pick the HTML file that we just created. Okay, and here we have all those openings that should be created. Right now I'm going to switch all those host information, and here we can very easily change the cut offset, so it will be additional offset around the ducts and pipes. Now we can go to insert and modify openings dialog, and here you can very easily make filters. You can filter only the openings that will be created for the floors, and then we can filter only the wall, the openings that will be created for the wall panels. Also, we will be able to see that in our project very easily. And if we want to insert them, we can just go to the right click and just press insert or update openings. And now there are 7 openings inserted. Okay, and right now all those rows are green. It means that everything is okay and we can see results. And after creating those openings, we can come back again because we did changes with our wall, so we can very easily update our assembly. So now the tool will update assembly, and it automatically includes the openings, and the tool automatically will add dimensions on such openings. That's it, and we can check results. So we can just go directly into our sheet. We have those openings in our assembly, we have it in the 3D view, and at the same time we have those openings in our dimensions in every view. And now if we make any changes with our MEP project, let's say I'm coming into our MEP model and I will make some little change, we can save this model. We can come back again to our structural model. Right now I will update this link. Okay, so as you can see, yeah, we did some changes. So after making those changes in the MEP file, it's very easy to update the openings. We can come back again into interference check. Again, we have to load the same scenario. We have to find the differences between those ducts, pipes, and walls and floors. There is one collision. Let's update. Let's create updated HTML file. And now let's read this interference check. And the tool automatically will show you that this opening was modified and we have changed its position. So the tool automatically will let you know that those openings should be updated. And again, you just need to press with right click menu and press insert or update openings. And that's it. Every row is green, so it means that everything is okay, and we see those changes. And now if we will check it again, let's check again. Let's find again interferences between those elements. And there are no interferences detected, so it means everything is okay and we have created all those openings. Okay, now I'm switching the screen to balancer screen, because balancers will continue with other elements, with the columns and with the floor panels.
Okay, thank you, Renata. I will continue from here. I will show some tools how to use on this my frame building. So I will use smart floors, insert elements, and create assemblies. First of all, I would like to see here some foundations. So I'll select columns where I want to place my foundation. So I'll do it in 3D view. I will hit insert elements and I will choose to insert foundations that I have loaded here already, and I will place it related to the column base point. So I'll hit insert. Okay. You can see here now foundations inserted, and I want to insert here other type of foundation, so I will choose again foundations and insert. Okay, so I have inserted these foundations in just a few clicks. If I would do it in the plan view where a project is big, then it kind of takes a lot of time to find the right position, not to snap to the wrong point, and to insert foundations where they should be. Okay, so I have foundations, and next thing, maybe I will go to smart floors to make some floors between these beams. This is the plan view of second level, and now I will select smart floors tools, insert update floors, and this is the dialog box for our tool. I will just make all configuration, and we will see how it goes. So group name is number 1. I will select start, support, and support. So I just click on the beams and layout beginning on this side and layout then on here. So now we have floor panel width, which will be inserted, is 102,000 millimeters, and the length is 5,350 millimeters. So this is the parameters of panels which will be inserted. But I would like to extend these floors on the beams seating, so I will add these millimeters here, and the length of panel is increased. But tool will create a floor panel, so usually by default in Revit, floor panels don't have any parameters for their width and length, which will be included in schedules later. So I will hit here and add parameter, shape parameter for the width and shape parameter for the length. Okay. Now, next thing, I will select the type of the floor. This is basically the thickness of the floor, which I defined before, and I will choose to insert holes and the size of the holes. Okay, now the layout length is 27 meters and 400 millimeters. So there will be 22 panels with 1,200 millimeters width, and it will be like 26 meters, 400 millimeters. And it's less than wall layout length. So we have 1,000 millimeters left, and tool will insert here a cast in place element of the depth of 1,000 millimeters. So we can leave it like this, or we can, let's say, change the layout length. So tool will insert only these 22 panels, and there will be an empty place in the end of the layout, so you can insert later one panel or maybe something like this. And okay, so I have defined everything I need, and I will hit insert. Okay, let's take a look now. We have here floor panels and holes inserted. So I will go to the view, and you can see that panels were distributed from the beginning, from the edge of this view, as I selected it from all layout rule, and we have here a gap of 1000 millimeters as we defined it. So it's pretty quick, and we can do schedules. I have prepared here a schedule table for all these panels, so we can have the type, the width, length, concrete, glass, and the number of panels inserted. If we will add like mark, we can do some numbering quickly. Choose floors, date, add all, select floors, insert mark, select the elements, go. Okay, and we can do drawings. We can model quickly with the right views, and we can do schedules for these elements. So it's pretty quick, and it takes everything we need. Okay, so let's go back to 3D view, and let's use some insert elements tool again. I will select now all the frames, and I will select insert connection detail here. I have a family for such connecting detail. I will select it to place it on the start and the end faces of the beam. I'll hit insert. Okay, so we have now these connection details at every end of the beam, and you need to insert also connection details into columns. I will select these 3 columns. I'll select insert elements just to take a look how it works, and we will insert few elements in the columns. These ones to connect the beams. So we will insert elements according to the place of the beams. We will also insert column shoes at the bottom face of the structural column, and we will insert anchor and balls on the top face of the structural column. So, okay, I will insert. Okay, and now we can see for the columns we have selected. We have column shoes at the bottom, we have anchor and balls, and we have connection details. So, as Renata said, all these elements are just regular face-based families created, so you can create any type of connections you use in your projects, in your country. So it's just the workflow of how to use it, but it's not limited to some specific type of connections. You can also insert here and nodes to connect our columns to foundations. I will just choose anchors, and I will place on top place. Yes. So this is how to use insert elements and smart floors to make some comments easier. And now I will also run into smart assemblies quickly. Let's say I will select one column. I will create assembly. With our tool, I will select the right configuration, and I will do OK to create. Okay, and we have one more drawings here that all our elements inserted. We will have views defined, and we will have concrete schedule table, part list for this element, and we can just paste these views to the drawings and use them like a template for other columns. It's pretty the same workflow as it was in the wall panels. If we choose configuration to use this as a template, and we can do drawings again. Let's go to 3D view again, and let's say this column. We'll change the marker. Create assembly again. Column and create. Okay. So we can do with more elements at once to select all the columns, and not only create all these sheets with predefined configuration. But I don't want to wait too much for this operation, too much. And now we can also create assembly for a BIM. I will choose. Okay, we don't have a mark parameter here. Every assembly must have something. Okay, I will add it. Okay, hit assembly and choose configuration. Back a little bit, and let's go and check column. You can see the view from the left, and the front, top view, and also schedules. So we can do the same drawings and use these drawings as templates for other views and so on. So this is what I wanted to show today, and maybe another will take over.
Okay, I'm coming back again into my screen with a conclusion. Actually, our promise to our customers is reducing BIM stress, and we help to eliminate tasks that we do not create value at all. And you are welcome to join our community. Actually, anytime you are welcome to ask questions. For the most of the questions we have answers, because we develop products for Revit about 8 years already, and we have many solutions. But at the same time, if you see that something needs to be improved, or maybe some additional product needs to be done, so you are welcome to join our community, and we will be looking for your new ideas.